Okay, so when you see roots, the roots are the places where it touches the x-axis. They're either going to be a single, like a cut through, like this one. Sometimes you call them straight. This one's a bounce, and that's worth a multiplicity of 2. And this one's a triple, and that's sometimes we call it a snake or a swerve, and that thing is worth a 3, a multiplicity of 3. All right, so you could ask the question this: if it's a multiplicity 1, what will you see? A cut through. What's the word for the 2? Bounce. And the last one is what? Snake. Technically, that's where it goes from increasing at a decreasing rate to increasing at an increasing rate. At that little point of inflection, it's called. An inflection point is where things like change over. It's sort of like that's the day that I decided I was going to be the best snorkeler in the world. At that moment, it changed trajectories. Snorkeling. It's awesome. Have you ever been snorkeling in the ocean? Raise your hand if you've had a chance to do that. It is so cool. Especially if you're in a place that's really nice for it, like either in the Bahamas, it's really clear water and warm, and that's pretty awesome. Or in Hawaii is another pretty good place. You can see some amazing fishies. And I got to see a turtle once too. That was pretty cool. My best day ever was snorkeling, where I got to see 3 tarpon, and these are huge game fish, like way longer than me, swimming around eating minnows, and they looked like a giant minnow themselves. They were like bright silver. Anyway, that was really cool. On that same day, I saw a what do you call those? A special kind of lobster that's in the Caribbean. I think it's Caribbean lobster or something like that. Very unusual. Yes. Great Barrier Reef. Wow, that would be so cool. All right. So, how many times does this touch the x? Well, you could argue and say it touches it twice, there and there, or you could say that it touches it 3 times. Why would you count this for 2? Because it's a bounce. It's double root. Multiplicity of 2. All right, so this is degree 3. Does it make sense it's degree 3? The things are going opposite directions. Is that what you want on a degree 3? Yep. And how about the lead coefficient of it? The number at the very front, would that be positive or negative? Positive, because it's going up on the right. That ends up meaning it's a positive in front. All right. Now, this says, what's the lowest possible degree? I say it's degree 3. But why do they say it that way, the lowest possible degree? Yes, because there could be roots that you can't see that are imaginary. Like, for instance, a bounce could actually have 2 imaginary roots at the same spot where the 2 real roots are. So, yes, this could be more than degree 3. There could be imaginary roots that make it degree 5 or degree 7. Could it be a degree 8? No, because their ends are going opposite directions. We know it's an odd one. So it's either 3 or more is the way you say it. All right, so the lowest possible degree is 3. 2 for this, 1 for that, so it's at least a 3. Could be more imaginaries I can't see. All right, write the equation of the function in factored form. I'd like you to write this one with me. Y equals, on your paper. Well, I need 2 sets of parentheses. So this spot right here is negative 3. That's where x is negative 3. How am I going to write that? X plus 3. And it's a multiplicity of 2, so squared. And then this spot right here is a positive 1, so what do I write? X minus 1. That way the 1 could go in there and solve it. And that's a cut through, so that's only worth 1. And there it is. Now, could there be a stretch factor in the front of it that I don't know about? Yes, there could. So we could put an A right there, and you could solve for that stretch factor. All right, and if I needed to know what that stretch factor was, I would put in an X and a Y. I put in my X here and here, and I put in my Y right there, and I'd solve for the stretch factor. But one thing you can't do is use one of the zeros, so I'd have to use some other point like this one. And I could stick in the X and the Y. X is 0, Y is negative 18, and I could solve, and then I'd know what the stretch factor was. Yes? you should put the A there. Just put the A there, and if you don't know what it is, you can't figure out what it is, you just leave it as an A. But if you can figure out what it is, well, I'm not sure how far we're going to push you on this. We'll know that by later this week, whether or not I'm going to make you do this, but I would put the X is 0, and put it in here and here, and the Y is negative 18. I'd put it in right there, and I'd solve it for A. It's not that hard. Okay. Here's a review of the end behavior in mins and maxes and extremes and increasing and decreasing. This is all going to be part of either the graphing test next week or the communications test next week. So if I said end behavior, it's just either up or down, and what would you say in this one? Up, up. They're both going up. Absolute max, do you have one or not? No, there's no absolute max. Don't say infinity because that implies that we can get there and the max is infinity. I know it's splitting hairs, but usually say none. No max. If the answer is infinity, we say no max and no min. Because as soon as you say it got to the maximum, it implies it stopped. And it'll never stop. Oh, I'm sorry. Sorry, there is a min. Sorry. Okay. And the min is right here or there. Just trying to put those 2 points on there. So now I've got 2 mins. Those are both local mins, and one of them is the what? Absolute min. And I think that one is the lowest. You guys agree? All right, so then that is at -5 comma -6. And so that's my absolute max. But it's also a local max. Min, sorry, min. And this is a local min, not the absolute min. What's that? Local max. All right. Extremes. This point and this point and this point. Why don't I circle the ends? Because they're not spots. They're infinity. It's a concept. It'll never get to infinity. So the extremes are the local mins and maxes. All right. Decreasing and increasing. Is this blue graph ever decreasing? Yes. Whenever you're reading from left to right and it's going down, then that is a spot where it's decreasing. Like right here, it's decreasing as you go from left to right. Right until you get to that spot. Okay? And so that is decreasing from negative infinity. Remember, it's a left-right thing. From negative infinity until you hit -5. And then increasing, we could say from -5 until you hit -1. It was increasing. And there's more spots where it's increasing or decreasing. Do you get these things? I think this is the easy part. Okay, good. Moving on. This is pretty much the same kind of a thing, except it asks for the equation, so we're not going to do all of this because it's repeat. But the equation for this is not. Just, I need to make sure how many of you can do this right. Write me the equation for that red line. And you could figure out what A is by using that nasty decimal, 3.2 comma 16.3. But I'm not going to ask you to figure out what A is. You can just leave A as A. Yes, sir. You could actually use that point. You could use the point down here is what he's saying. You're right. But don't. For right now, I just want you to know how to set it up, not actually solving for A. So you have A, and then you have sets of parentheses. And the first one, it doesn't matter what order you do them in, but they're here, 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 and here. And this one is at -5, so I get x plus 5, and it's a balance squared. And this one's at -2, x plus 2, and that one's cut through, so it's a 1. And this one's at x minus 1, and it's a cut through, so it's a 1. Does it make sense that this is a degree 4? Yeah. Could it be a degree 6? Yes, it could, because it could have imaginary ones we can't see. Okay? All right. Yes? Question? There will be imaginary roots that you can't see anytime and anywhere, and you never know. So that's why when you are asked, what degree is this? You would say, well, it looks like it's a degree 4, but it could be more. You always have to hedge, because you never know for sure. The only time you would know for sure is if they don't give you the picture, if they give you the equation. So if I give you an equation like this, I can know for sure whether there's real or imaginary roots. Okay, but if I have a picture, I never know. On this kind, if I want to know for sure, I know it's got 5 roots. Okay, then I would want to take that and graph it. Once I graphed it, let's say that it did this. Squiggly-doo and goes down through like that. Actually, I just can't go back up again or it won't work. There we go. It looks like it's only a degree 1. But that means that there's 1 real root. And you'd know for sure then that since there's got to be 4 more answers, that there must be 4 imaginaries. Okay? All right, so you can't tell by looking at a picture whether or not it's for sure. This one looks like it's a degree 1, but it's 1 or more. And in this case, we know it's degree 5. All right, all we can tell for sure is the real ones. All right, let's talk about limits again. This is important. This is a big topic in calc. Have any of you taken the SAT or ACT test yet? Did you see limits on there? All right. Some of you say yes, some of you say no. And it does depend. Depends on the test. It apparently isn't a big part of the test. But all right, this, those are all roots, right? Do they tell me a limit at all? No, it has nothing to do with the limits. The limits is where it will be if I go where it tells me to. If I go where x is infinity, that's like way over here, then they've told me x. What do they want to know? The y. What will the y value be where x is pretty much infinity? Well, the y value would be pretty much positive infinity. If I go to x is negative infinity, that's way over here. If I go way over there, what would the y be? Positive infinity again. So notice this is kind of like end behavior. So a lot of times a test question you would have would be like this. Write the left end behavior in limit notation. So the left end is way over there, right? And so that's the limit. They always have a lim of the function as x approaches. Every single limit problem always starts like that. That's like the boilerplate. You always have to have all those things. Then it's like, where do you want x to be? If I'm talking about the left end, it's way over here, so that's where x is negative infinity. And now I want to know what the y would be. What would the y be way over there? Negative infinity. Because way over here, the y value goes way down there because of this. All right. So I just wrote the left end. Would you please write the right exact string of characters to tell me the right end behavior in limit notation on your paper right now? Yes? Nope. These are always limits as x approaches something. We don't do limits as y approaches something. We never will, and I've never heard of it. Doesn't mean it. I'm sure somebody somewhere studies that, but also in calculus it's as x approaches stuff. All right, hopefully you started with lim of the function as x approaches, and in this case what? Negative infinity, that's the left end, is equal to, and now we want to know what the, wait a minute, the right end. Sorry, that's supposed to be positive infinity. And, because we're way over here, and then if f of x is approaching, sorry, if x is approaching infinity, f of x, which is also known as y, is approaching positive infinity. Raise your hand if you had that one right. Okay, good. All right, I think you get basic limits. Here's more complicated limits. All right, this is the kind where instead of going way over this way forever, or way over this way forever, we're talking about coming into the middle. If I'm coming in towards 0 here, it depends which side I'm coming from. If I'm coming from over here, as I get closer and closer to 0, it goes down to negative infinity. But if I'm coming from over here, and I get closer and closer to 0, then the answer means positive infinity. So here's how you can tell. This little thingy right there, that means the limit of f of x as x approaches 0 from the negatives. So that's this one, where I'm coming from over here, from the negatives. You can see where it's going to head. What's the answer? Negative infinity. Because it's going to go down there. And this guy, x is going to get closer and closer to 0. When x is pretty much 0, but coming from this side, then the answer is way up there. Positive infinity. I'm going to give you another one because I gave you that one yesterday. So I'm going to draw this picture. So it looks a little weird, but I think you'll get the idea. And then this one. Give me the limit of f of x as x approaches 0 from the negatives. And then give me the limit of the function as x approaches 0 from the positives. Take your best guess. Write it on the paper. Just a simple answer. What do you think that first one is? Infinity. Because I'm approaching from the negatives, which is over here, and I'm going this way, and as I get really, really close to 0, that's way up there, and it's therefore going to be infinity. This other one, I'm approaching from the positives, which is over here, and I'm following this line right here. And then I get closer and closer, and when I actually am at 0, there is an answer. It's 3. You get that? Yes? That one is called 1 over x. Yep, if there's an asymptote, then you're going to be approaching that asymptote. Yes, you're right. I think I know what you mean. Like in this one, let's say they were to say x approaches like 3, even though 3 isn't even, you know, one of the asymptotes. We won't do that to you, but they will in calc. And just so you know what they would do there, let's say as x approaches 3, well, 3 is right between 2 and 4, right? So let's say 3 is right about there. They would just want to know what's the y value right there. That's pretty much what they're asking. And it's pretty much the same thing either way. Now, if I drew the picture funny, though, and said, here's empty spot here at 2, and then picks up again here with an empty spot like that, they could ask you the limit as x approaches 3, limit of the function. And I'd have to know both ways. As x approaches 3 from the negatives, would be from over here. And as x approaches 3, coming from this side, the answer would be 2. Even though it never hits 2, it gets infinitely close to 2. So I'd say 2. And if it was approaching from this side, then from over this way, I'm going to eventually get, and that would hit right about here, and then it's that spot right there. Because it was coming from, you know, this is where it was, and it was getting really close to that. So the answer would be -2 if I was doing the limit as x approaches 3 from the positives. It would be coming from over here. It would be really close to that spot, which would be -2. Okay? All right, just a little advanced thing there that you guys don't have to know yet. All right, so if I gave you this, you'd have to be able to tell me its end behavior. That'd be a really easy thing to do. You'd look at the number in front, and since it's positive, that tells you the right is what? Up. And since this is even, what do you know? Also up for the left, because they have to go together. If it was odd, they'd have to go the opposite direction. Write the end behavior as a limit. We just did that a second ago. Would you be able to handle that? Limit as x approaches infinity. Which side is that? The right or the left? That's the right side. And the limit as x approaches negative infinity, that's the left side. Take a guess what those two answers are. Write them down, and I'll tell you if you're right or not. So this is the right side, and since we said up, that also tells you it's infinity. And this is the left side, and since we said up, it's infinity again. Raise your hand if you said infinity and infinity. Good. Y-intercept, just don't forget that it's not negative 8. It is negative 8, kind of. But if you just write a negative 8, you get it wrong. A y-intercept is something comma something. And the y-intercept is where x is 0. So it's 0 comma negative 8. Okay? Fine point, but don't want to get things marked wrong for dumb reasons. All right, here's one more. Please answer this one from beginning to end. Tell me its end behavior on the left and the right. Then tell me its end behavior as a limit. And then tell me its y-intercept. All right, I'd start with the right side. And the right side comes from this, and that's down. Then I'd ask myself, is it even or odd? It's even. Degree, and therefore they got to be the same. Down. Left down, right down. And behavior is the limit. JJ, tell me how to write this. And that's which side, the right or the left? Okay, on the right side it is negative infinity because it's headed down. Very good. And then call on somebody else to do the other part. Okay. Lim. Okay. You got it. And the last thing is the y-intercept, and that is just don't say 5. What? 0 comma 5. All right. Any questions on those? All right. How about this? Find the zeros algebraically. Last thing we got to know. Well, that means you can't graph. Otherwise, if you could graph, it'd be really easy. It'd go like, oh, look at it. Touches here and here. Those are the roots. But how can I get them if I can't graph? Factor it. And if you can't factor it, use quadratic formula. But what happens when you're on a cubic? Can you use the quadratic formula on that? No, you cannot. Therefore, it has to factor or you won't be able to answer it. Okay? Go ahead. Both of these are easy to do. Just tell me the answer. Don't graph. Tell me the answers. Remember, you're trying to do like the... Well, you could do the quadratic formula on the first one, I guess, if you wanted to, but it's probably a lot easier if you just factor it. Remember, you always start by setting this equal to 0 because we want the x-intercepts, also known as the zeros. The x-intercepts are where y is 0, and that's why we make a 0 here. And this one, that's factored, but it's not the answers. The answers are 1 and 1. Kind of weird, but yes, there's 2 ones because it's a double. It's a bounce. That means that it bounces at 1. Boing, like that. All right? And this one, you got an x pulled out to the front if you're good at factoring, and then you have 3x squared minus x minus 2, and then hopefully you're good enough at factoring to handle that, x and 3x. Doesn't matter if this 3x is in front or not. And then one's got to be a plus and one's got to be a minus, and it's just guess and check from here. I'm going to try being a positive 2 and a negative 1. And the outside and the inside give me, let me see, 5. There are 6x minus an x makes 5x. That's way off. If it's way off, I switch the numbers around. Put the 2 here and the 1 here. And now I try it. Outside, inside makes positive x. Ah, now I'm close because it's the opposite of what I want. So now what do? Switch the signs. Instead of a plus and a minus, I do a plus here and a minus here. And then I check it, and the outside and the inside now add up to negative x, which is what I wanted. Yay. Final answer, x equals 0, x equals 1, and x equals negative 2/3. If you don't know how to do this part, it's because 3x plus 2 equals 0, 3x equals negative 2, x equals negative 2/3. Okay? That's how you solve things algebraically. You factor them. And if they wouldn't have factored, then I'd go to the quadratic formula, like on the ones that are quadratic. Like that. Don't forget the quadratic formula. It will come up again and again. All right. now you know everything you need to know for today and tomorrow, and your assignments are on the board here. For those following along at home, I'll write them out for you quick. Tuesday it's page 209, 17 through 23, 26 and 28, and 33 to 41 odd. Then on Wednesday it's going to be page 209 again, 34 to 42 even, 49 through 59 odd, and 61. Okay, and I will be gone tomorrow, so there will be no video, but I've covered everything that you need to know for those assignments.